Now, the thing about chemists is they don't really count stuff. It would be impossible to count the number of atoms or molecules in an iron chain. It's much easier for them to use masses, using a balance. So that tends to be their way of measuring how much stuff they have. If we're going to solve problems using masses, like we did with the sandwich cookies, we need to know the mass of one. Lucky for us, there is a very good resource that tells us the mass of one of every element. It's the periodic table. So let's look at our periodic table and find the mass of one iron. Side note, I like to use ptable.com when I have to quickly find information about an element. It's pretty detailed, which is great for some things, but we only need the masses, which are those numbers at the bottom of each element box. So we're dealing with iron and oxygen. The mass of one iron is 55.85 grams. I'm going to round to the nearest hundredth on this, and we'll even round more as we get through on the questions, but I'm going to leave every element measurement to the nearest hundredth. And the mass of an O2 is 32.00 grams. The mass of an Fe2O3 is 159.69 grams. So we take 2 irons and add it to 3 oxygens, and that gives us a mass of 159.69 grams. Now your values may vary slightly, and they might be a little different than this depending on how you round or what periodic table you use, but just know that I'm going to be using ptable.com, and if you're off by just a little tiny bit, that's really no big deal. So really, this is the mass of 1 mole. These grams are measuring the mass of 1 mole of whatever element or compound we are talking about. But if we just say the mass of 1, our calculations will still work. Back to this car. Did you know that a rusty car technically weighs more than a non-rusty car? Let's take a look at this question. The outer layer of a car is made up of 154 grams of iron. How many grams of rust will it produce? So we have 154 grams of iron, but how many irons is that? Remember, we'll always start by dividing by the mass of 1. 154 divided by 55.85 is 2.757. I'm going to keep a couple extra numbers after the decimal, and then at the end, I will round. So there are 2.757 irons, or moles of iron. Next, we need to know how many moles of rust will be produced. This is one of those how many problems where we use the coefficient ratios. 4 moles of iron will produce 2 moles of rust. So 2.757 moles of iron will produce 1.379 moles of rust. So I multiplied by the find coefficient 2 over the given coefficient 4. Now that we know how many rust moles we have, we need to figure out the mass of this. To figure this out, we need to multiply by the mass of 1, which in this case is 159.69, which gives us 220.13 grams of rust. To keep in line with the correct number of significant digits, I'm going to round my answer to 220 grams of rust. So the outer layer of iron went from 154 grams to 220 grams. Was it magic? How did it get heavier? Well, the oxygen from the environment reacted with the iron to form a heavier, more complex compound. Let's do another problem. I want you to pause the video and try this one on your own, and then play the video back and check your work. we are given 16 grams of iron, and we're asked to figure out the mass of oxygen that reacted to it. First, we need to figure out how many moles of iron we have. We'll do this by dividing by the mass of 1. 16 divided by 55.85 is 0.286. This is how many moles of iron we have. Next, we need to use the balanced equation to figure out how many moles of oxygen this will react with. So 0.286 times 3/4 equals 0.215 moles of oxygen. Since the question is asking about the mass of oxygen, we need to multiply our answer by the mass of 1 O2. 1 oxygen, or O2, has a mass of 32.00 grams. So 0.215 moles of O2 has a mass of 0.215 times 32, which equals 6.875 grams. And we're going to round to 2 significant digits because that's how many are in the number given to us. So this would be 6.9 grams of O2 from the atmosphere chemically bonded to that car door to give us iron oxide. Now, one method you will often see scientists use to solve problems and make calculations is something called dimensional analysis. This is a way of showing how the units cancel out using a series of conversion factors. So if we were to write out all the work to this problem using dimensional analysis, it would look something like this. Having a good understanding of dimensional analysis is really helpful when solving problems involving measurements.